Welcome. My name is Adam Lynch, and I'm a Partner Solutions Architect based in sunny Brisbane. AWS is a self-service platform, and many customers need assistance in delivering projects, and this is where the partner community can help. As a Partner Solutions Architect, my role is to work with these consulting and technology partners to help you get the most out of the AWS platform. Today, I'm going to be talking about computer vision at the edge and how you can leverage the AWS services to build solutions yourself. I'm also going to take you through two customer examples and show you a demo of how you would build, train, deploy, and optimize models for the edge using the AWS stack. Computer vision is used across most industries to help solve business challenges, enabling capabilities across many industries and use cases, from things like public health with medical imaging and clinical diagnostics, retail analytics in checkouts and customer heat maps. The Amazon Go store is a great example in this space, where you walk into the store, pick up the items you want, and walk out. The computer vision in the store tracks you and what you took from the shelf as you walk an aisle and subsequently bills your account. We're also seeing usage in media and entertainment with targeted ads based on the content of the previous show and the ability to categorize large amounts of archivable footage programmatically. And finally, in industrial and manufacturing for both fault and quality assurance and worker safety, which I'll show you several use cases on today. On top of this, we're seeing a focus on running these models on the edge. As more and more applications such as industrial robots, autonomous vehicles, and automated checkouts require models that run on smart cameras and equipment, these applications need low latency and near instant results. We're also seeing that the improvements in processing power are enabling new and exciting use cases that were previously too complex or expensive to run in all of the largest use cases. And this is where AWS is leading the way in democratizing access to their best ML tools for any level. From the developer to the data scientist and everything in between, we have a tool that can help on the journey. We're innovating on behalf of our customers to deliver the broadest and deepest set of machine learning capabilities for builders of all levels of expertise. At each layer of the stack, we're investing in removing the undifferentiated heavy lifting so your teams can move faster. At the top layer, you'll see our AI services, which allow developers to easily add intelligence to any application without needing machine learning skills. At the middle layer is the Amazon SageMaker layer, which provides every developer and data scientist with the ability to build, train, and deploy machine learning models at scale. And at the bottom layer, expert practitioners can develop on the framework of their choice as a managed experience in Amazon SageMaker. Or they could choose to use the AWS Deep Learning AMIs, which are fully configured with the latest versions of the most popular deep learning frameworks and tools. And you can see highlighted here, these are the services related to computer vision. First, we have Amazon Rekognition, which provides image and video analytics from everything from object detection, facial analysis, and content moderation. We then have Amazon TextTrack, which automatically extracts printed text, handwriting, and other data from scanned documents. And new at reInvent last year, we launched AWS Panorama, a device and SDK that allows organizations to bring computer vision to on-premises cameras. And we also have Amazon Lookout for Vision, which is a machine learning service that spots defects and anomalies in visual representations using computer vision. But today, I'm going to be focusing on SageMaker and deploying to the edge with IoT. So what are some of the real-world use cases? When the COVID-19 pandemic began, many of the talented engineers in the Amazon.com business rallied to support the health and safety of our associates working to get the customers the products they needed. As they reimagined workstations and implemented new processes across their facilities, the engineering teams looked for ways to help maintain social distance. One of the early solutions they developed applies artificial intelligence and machine learning to the camera footage in their buildings to help site leaders identify high traffic areas and implement additional measures in order to improve social distancing. Given that social distancing isn't always a natural thing, this team set out to use augmented reality to create a magic mirror-like tool that helps associates see their physical distancing from others. Working backwards from the concept of immediate visual feedback and inspired by existing examples like radar speed check signs, the Distance Assistant provides employees with live feedback on social distancing via a 50-inch monitor, a camera, and a local computing device. The standalone unit uses machine learning models to differentiate people from their surroundings, and combined with depth sensors, it creates an accurate distance measurement between the associates. As you can see here in the video, as people walk past the camera, a monitor displays a live video with visual overlays to show if the associates are within 6 feet of one another. Individuals remaining 6 feet apart are highlighted with green circles, while those who are closer together are highlighted with red circles. The on-screen indicators are designed to remind and encourage associates to maintain appropriate distance from each other. The self-contained device only requires a standard electrical outlet and can be quickly deployed to building entrances and other high visibility areas. The code for the solution is also available for anyone to download and deploy themselves, and I'll share the link to the example at the end of the presentation. Another example is a solution built by AWS technology partner BigMate. Their Warning system has helped customers like Boral and Visi improve worker safety in their warehouses. The Warning technology, utilizing the consistency and reliability of artificial intelligence and machine learning, coupled with the use of existing CCTV cameras to monitor the environment, provides a solution that is both effective and cost-efficient. The system processes information in real time, observing and understanding the relevant occupational health and safety rules, and shutting down machines where necessary to avoid harm. It works by detecting workers and vehicles in the workspace, tracing their trajectory, and warning when they are too close to each other. As it's integrated with existing CCTV, it is easily retrofitted to existing workplaces. Monitoring of the movement of people around the industrial equipment enables a continuous eye on the safety by continuously tracking people's movements and ensuring that they do not stray too close to the machinery. The system is highly configurable, and by using multiple alert levels when the machinery is in operation, if a person is within an orange zone, then an alert can be raised. If they move into a red zone, the machinery can be stopped. It uses the dynamic safety zones that allow the drawing of zones around any machinery, which are used to identify the orange and red zones. This combined with the depth calculations, it can effectively apply a 3D view to ensure the person is in the zone in question. And this is what it looks like in action. Where there are vehicles such as forklifts and pedestrians occupying a warehouse, workshop, or other environments, Warning continuously detects, tracks, and assesses their proximity to each other. It then identifies when a person and vehicle are too close or on a dangerous path. The solution uses a combination of artificial intelligence and machine learning together with predefined rules to detect proximity breaches. Once a breach is detected, it sends an event to the Insights platform together with an image of the event. It can also trigger other actions such as a local alarm, like a flashing light, or a siren, or send an email or SMS. The platform captures data that keeps OH&S staff aware of all the events, and management dashboards allow the evaluation of site, regional, or country performance. A key part of any ML system is the reporting side. All the data gets pushed up into a database for reporting, and analytics is available for safety teams. Incidents can be reviewed, and training can be provided. So computer vision comes with a number of challenges. Development life cycles take time, and getting the right people can be difficult. The cost of model training and inference can be expensive, and it can be very hard to predict the budget required for the project. And when it comes to building and managing models, dataset labeling can be very manual and costly, and also time-consuming, and you have to deploy and manage it in production. The other complexity is the spectrum of offerings in the space. From AI services to full custom models and everything in between, the level of expertise required gets greater and greater, and the skills in the market can be hard to find. And this is where AWS can help. From developers to experienced ML practitioners, we have you covered. From data labeling to leveraging the AI services for image and video recognition and anomaly detection. You also have the ability to develop your own custom models, leveraging the best tooling to reduce friction in your development lifecycle. We have tooling for deployment to the edge or the cloud. And finally, we have human-in-loop options to augment your ML models. When starting a computer vision project, If possible, it's best to use an AI service like Amazon Rekognition to pilot your project. An API-driven service will get you to a proof of value faster and doesn't require as much expertise to get results. And then when it comes to building accurate custom models, you need quality labeled data. And labeling can be a time-consuming process, and the workflows can be very complex. SageMaker Ground Truth provides you with built-in workflows for public, private, and marketplace workforces that allow you to label your data, and it gives you the power of AutoML to bring down the cost of labeling over time. Amazon Rekognition allows you to leverage the power of an AI service to detect objects, people, text, scenes, and activities in images and video, as well as many other features. It also lets you train to detect custom objects that you can label with Amazon SageMaker Ground Truth, like logos and other company-specific items. So if you can use an AI service, start here, as you'll get up and running faster. We also have all the custom build tooling you need. Amazon SageMaker provides training using low-level deep learning containers, optimized for AWS instances. You can leverage model zoos or built-in algorithms, and even BYO containers and options from the ML marketplace. You can train your models with SageMaker on PEG or Trainium instances, amongst others, and pay by the second. You can use hyperparameter tuning jobs to help choose the optimal weights for your training jobs, and distributed training lets you fan out across multiple instances. The debugger and profiler helps you, train your model and understand what's going on. Spot instances help you bring down the costs, and experiments manager helps you experiment right from the power of your SageMaker notebook. We have pipelines, which is an MLOps tool, and all this is underpinned by the deep learning AMI on EC2. And as mentioned before, we feed all of this with quality labeled data from SageMaker Ground Truth. And once you put all this together, you're ready for deployment. On the inference side, SageMaker handles the scaling for you. You can optimize your models with SageMaker Neo, then you can run your inference in the cloud or on the right instance for your model. From NVIDIA GPUs to Amazon Inferentia, our custom silicon, we have the options that can suit any workload. And when it comes to running our inference on the edge, Neo supports the most popular models and platforms, from NVIDIA Jetson to Raspberry Pi to Qualcomm QC and other chipsets. And all of this can be integrated with other AWS services for reporting and reinforcement, like augmented AI for human-in-the-loop models. Edge-based models add even more complexity. Whether it's security, versioning, deployments, and software updates, there are many things to keep on top of. And this is where AWS IoT comes in. Using the power of Amazon SageMaker to build and train the models, then AWS IoT to deploy and manage on the edge. AWS IoT Greengrass makes it easy to perform machine learning inference locally on devices using models that are created, trained, and optimized in the cloud. IoT Greengrass gives you the flexibility to use machine learning models trained in Amazon SageMaker or to bring your own pre-trained models stored in Amazon S3. Training and optimizing machine learning models requires massive computing resources. So this is a natural fit for the cloud. But inference takes a lot less computing power and is often done in real time. Getting inference results with very low latency is important to ensure your IoT applications can respond quickly to local events. IoT Greengrass also gives you the best of both worlds. You can use machine learning models that are built, trained, and optimized in the cloud and run the inference locally on the devices. For example, you could build a predictive model in SageMaker for scene detection, optimize it to run on any camera, and then deploy it to predict suspicious activity and send an alert. Data gathered from the inference running on IoT Greengrass can be sent back to SageMaker, where it can be tagged and used to continually improve the quality of the machine learning models. And AWS IoT Greengrass runs practically anywhere. Almost anything that runs Linux or a derivative, and even embedded devices running FreeRTOS. Your inference code can be packaged as either a Lambda function or as a Docker container. And as Python is one of the most common languages for these types of projects, it's very easy to get started. This is a simple workflow from SageMaker to deployed model. On the left-hand side, you can see SageMaker and the model artifacts that put into an S3 bucket. We then have a Lambda function to trigger the workflow. AWS IoT Core is configured for your device, and AWS IoT Greengrass runs the code on the device. And in this case, it's running on an NVIDIA Jetson Nano. At reInvent in December last year, we made it even easier. With the launch of SageMaker Edge Manager, you can now do even less management and have Edge Manager handle much of the configuration for you. Amazon SageMaker Edge Manager provides a software agent that runs on the edge devices. The agent comes with SageMaker Neo, so you don't have to have the Neo runtime installed on your devices in order to take advantage of the model optimizations. The agent also collects prediction data and sends a sample of the data to the cloud for monitoring, labeling, and retraining so that you can keep your models accurate over time. All this data can be viewed in the SageMaker Edge Manager dashboard, which reports on the operation of deployed models. And because SageMaker Edge Manager enables you to manage models separately from the rest of your application, you can update the model and the application independently, reducing costly downtime and service disruptions. SageMaker Edge Manager also cryptographically signs your models so that you can verify that it was not tampered with as it moves from the cloud to the edge devices. So how could you build a system like Warny for yourself? For example, what if you wanted to detect if workers were wearing their PPE on a work site? First, you would need to prepare a data set. Perhaps there's a public data set to use, but most likely you're going to need to create one. You'll then need to get accurate labels. For this, we can use SageMaker Ground Truth. We then choose an ML framework and model. Personally, I'm most familiar with Glue-on-CV, so I would use this as it has a great model zoo of pre-trained models, and I can use this as a basis for my transfer learning. I then set up an environment for training, and Amazon SageMaker Studio is perfect for this. I can then train and tune it and deploy my model straight from my notebook and prepare for testing. Once I'm ready for production, I use AWS IoT or Edge Manager to deploy and scale the production environment. So this is a demo I built to show the art of the possible for computer vision using AWS tools. The model detects if a person is wearing their hard hat or not, and alerts with a red or green box. And there's also a local feedback mechanism through an LED strip that changes color based on compliance. This simulates an alarm or gate locking mechanism to stop site access in real time. The model is built using SageMaker and deployed to a Deep Lens. The Deep Lens is a device that AWS produced to help customers learn and prototype computer vision applications. This is an edge device with a GPU and a camera, and is integrated with Amazon SageMaker and IoT to demonstrate the end-to-end process. And this is what the architecture looks like. We collected 400 or so images and had them labeled by a public workforce using SageMaker Ground Truth. I then used SageMaker Studio to build, train, and optimize the model. I wrote the inference code in a Python Lambda function, packaged and deployed it to the Deep Lens using AWS IoT. The model then runs on the edge device with Greengrass, executing the Lambda function that runs the model inference and publishes the results locally via the LED and the video output, and pushes an MQTT message of the inference back to the cloud where it can be collected for reporting. So let me take you through how it is built. First, we start with the SageMaker Ground Truth, and this is the view of the console of my labeling job. You can see that I've given the input dataset location and the output location for the S3 labels. I've specified a public workforce and used 3 labelers to ensure image quality, and you can see why this is helpful in a minute. You can see the 394 image count from the dataset, and now we can go over to the labeling tool, and you can see that I've asked the workers to draw a bounding box around the head area and hard hat. I've asked them to select the correct label for each, and you'll see me here drawing some bounding boxes around some heads here, just like the labeling workers would do. If we now go back to the Ground Truth job, we can look at some of the labeled images and look at the quality. You can see here the labels and the confidence rating. And this is important because we can filter out low confidence labels in our training job to improve quality. Ground Truth also consolidates the labels for you, and the more labels you have in your job, the more confident the percentage will be. So let's go over to SageMaker Studio and run through the training notebook. First, we start off by installing some packages for Glue-on-CV and OpenCV. The SageMaker environment already has most of the other common packages needed, so we just import our modules and set up our SageMaker session. We define the S3 bucket location, and as mentioned, I'm using a pre-trained model from the Gluon-CV model zoo and running a fine-tuning job to do transfer learning on the existing network. We download from the model zoo and upload to our S3 bucket. We now deploy the pre-trained model so that we can invoke workloads from a SageMaker endpoint. In this case, we're using an M5 large here, but for convenience. But in reality, you should be looking at using an Inferentia GCRM with the Elastic Inference module. Running inference on GPUs is typically much quicker, but comes at an increased cost. You should determine the appropriate instance type for your model prior to deploying it to production. We can now test the deployed endpoint by sending some of the images from the notebook instance. We can test and plot the predictions, and as you can see, the model is very good at detecting people and bikes, but doesn't know much about hard hats. So now we get into the transfer learning part. But first we need to load up our labels and images from the ground truth job. You can see here the JSON output for one of the labeled images. You can see the class map, the confidence rating, and the coordinates of the bounding box defined there. We can then plot one of these images, and you can see the bounding box. We run this image against our Model Z endpoint, and you can see that it detects people, but nothing else. So now we get onto our training job to teach it how to look at hard hats. But before we start the training, I run a hyperparameter tuning job to find the optimal weights for my training. This job passes the labeled images through the job to work out the best hyperparameters. And this job took 1 hour and cost 90 cents. I then added these hyperparameters into my training job in the next step. As you can see, we need to define an entry point file for the job because SageMaker doesn't have Gluon-CV installed natively and needs some instructions. This is the same method you can use for any framework that is not installed natively on the Deep Learning AMI. If I open up the training point file, you can see here that I'm showing SageMaker how to install Gluon-CV and set up the training environment for the job. I tell it how to use the ground truth labels, split the data set into train, validation, and test data sets, and I can set any other parameter that I want that's specific to my job. Now we go back and run the training job. And you can see that I'm using a single P2 extra large instance, which is a GPU instance type, and I'm doing 20 epochs. The job again took 1 hour, and again costs 90 cents. I then deploy the model to a SageMaker endpoint so that I can test the model. I'm using an M5 instance again, which I wouldn't do for production, but it's a good size for testing. I then load up some images and plot them against the model. And you can see here, even with a range of environments and lighting conditions, the performance of the model is pretty good. And as I'm now happy with my model, I then get ready to deploy to the edge. I run a SageMaker Neo optimization job to compile the model for optimal performance to run on the DeepLens device. And now I need to write my inference Lambda function. This is written in Python and it's quite straightforward. First, I load the models needed, set the variables, and pull in the video frame. I define the class map, and then I load the model. You can see here, I then execute the inference, and I plot the results on the video frame. And then the model loops over and over again to give us our output. We then go over to the AWS IoT device group. And in this case, I'm using the DeepLens, which has its own functions to trigger and deploy the model. You can see here the successful deployment, and you can see the Lambdas packaged for deployment. We can also flick over and see the resources that are defined on the local device. And as we're deploying with the DeepLens console, it all pulls it together and helps us deploy from one place. So let's look at the model running. And this is the solution in action. You can see the DeepLens device on the tripod with its output on the TV. The text on the left of the screen is the MQTT message output, and the LED bar on the bottom goes green when I'm wearing my hard hat and red when I'm not. This gives an example of a local feedback mechanism. The frame rate is a little slow as the device is using all its power on the inference code, and the display output suffers a little as a result. So how can we improve on this architecture? Well, first, to do that, we need to reinforce our model. To do this, we can opt out our inference lambda to collect images for retraining. Typically, we would capture low confidence frames for human assessment and relabeling. Because the function is running in AWS IoT Greengrass, we can simply use the AWS SDK and the IAM roles to either upload the images to S3 or use Kinesis to stream the images or video. We can then collect these and label them again with SageMaker Ground Truth and add them to the next training run. And then the cycle kicks off again. We can deploy, retrain, recycle. So if we look at this in the bigger picture, you can see how you'd build this out to a production system, leveraging all of the tooling discussed, plus collecting images and inference data to push into a reporting dashboard. You can use Amazon QuickSight or a custom UI as in the BigMate example. So to recap, build using AI services if you can, as you'll get faster proof of value. And for custom models, leverage Amazon SageMaker and the built-in tools and features. Use Amazon Edge Manager and IoT for deploying to the edge. And that's it for today. Go forward and build. Here are some helpful resources you might find useful in your journey. Learn more about the Distance Assistant and download the source code, or learn about BigMate's use of IoT and the lessons learned. There's also a link here for a self-paced SageMaker workshop. So you join the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS certification and training. We offer over 65 courses, many available free and on demand, as well as virtual instructor-led training. AWS experts will help you or your team learn to apply ML models to your business, unlocking new insights and value. When you're ready, you can prepare for the AWS Certified Machine Learning Specialty Exam, which validates your skills and provides an industry-recognized credential. For more information, visit aws.training/machine learning, and be sure to check out the AWS Ramp-Up Guide to learn more. Thank you very much for your time today. My name's Adam Lynch, and I've really enjoyed speaking with you. And please don't forget to complete the session survey, as it really helps us understand where we can do better in the future.